Well, many of us are keen to encourage new blood to this hobby to ensure its long-term future. But in the 21st century, it can be quite difficult to know how to inspire youngsters when there's so much technology and communications already around them. But John G7OHO has found a way to engage young people, and in a moment we're going to see a film about how he goes about it. And then straight afterwards, John and some of his young team will be joining us live. So please be sure to enter your questions and comments on the YouTube chat, and don't forget to put your name and your call sign, if you have one as well, in that message. So now let's find out more about John and the STEAMettes.
Hi, my name is Caitlin. Hello, my name is Millie.
Hi, my name is Alice.
Hello, I'm Natalie, Nat for short.
Hi, I'm John, G7OHO. As well as being involved with the Hildestone Radio Society, I help with the observatory at the Moncton Nature Reserve. I was asked by a primary school to give a talk about stars and planets, which I did. And we did an experiment with all the children to measure the size of the Earth, Eratosthenes experiment, which involved taking measurements of the shadow of the sun on the spring equinox, and we combined our results with those from other schools around the world. They then asked me to start a coding club, which I did, and I used the Arduino. Now, at the time, the Arduino was not as popular as it is now, and I struggled to find other schools interested in the Arduino. But I was able to find Joe and Julie in Australia who used the Arduino with their children in the primary school. So we had a challenge to set up a project, an artwork that involved flashing LEDs. The challenge with the children in Australia led to Joe and Julie sending me lots of kits to make multi-vibrator circuits. So that was very generous of them, sending it in the post with lots of information and guides and so on. So we made the multi-vibrator on a breadboard, and then later we soldered all the bits together to make the hypnotic owl.
We were very lucky to be sent these hypnotic owl kits by Joe and Julie from Australia to help us learn more about electronics and circuits. The end result is an owl with flashing blue LED eyes. The kit comes with everything needed and easy to follow instructions. My favourite bit of the build was soldering components to the printed circuit board. This was my first try at soldering and I really enjoyed it. This one, it's basically the same thing, apart from there are some different arrangements because this mini breadboard is bigger than the actual circuit board. But it does the same thing. It wasn't us who really got to choose whether we did it on the breadboard or the circuit board first. But I think it was because it was our first time soldering, and we also had to make sure that everyone knew where to put the things. We also had to learn what all the numbers and letters meant on them. And so it was just getting used to knowing what it would do when it worked. Along panel here on the breadboard, which is a bit moved about on the circuit board. Those are the resistors, and those are what you use to, like, you can use them to speed up the flashing of the lights and things. This one is a transistor, and it's what makes the lights flash, so it switches the lights on and off. And the LEDs are there because they're the lights that are flashing, and they're the eyes of the owl. The bit with the soldering was everyone's first time, so no one was better or worse at it than anyone else. And then we also got to do it ourselves, which is one of the best bits about it, because no one did it for us, and we got to do it ourselves. And the adults were really just there to supervise. Well, after we had actually got everything on the circuit, we had to cut a picture of this out from, I can't remember what we had to cut it out of. I think it was a sheet or something. And we were told to cut it out and stick it on the front of like some cardboard, so that it was more sturdy, because it would just flap around because it's just paper. And we had to make holes in the cardboard for the eyes, and then you just push the LEDs in.
Teaching soldering to youngsters wasn't easy. I enlisted the help of other club members who went round to make sure that they had proper solder joints. Yeah, the children loved it, of course, especially when they switched on and the lights started to flash. The Hildestone Radio Society offered to do a Christmas tree soldering exercise with the children. They bought the kit and we helped them to solder to make the flashing lights on the Christmas tree, which they loved, of course.
So this is the Christmas tree. One of the reasons why this is actually my favourite one is because we had a lot more space to put like the things on, because there's more space with the LEDs and things. And I was better at the soldering as well.
Today I'm going to show you how to make a paper circuit. You might want to use a paper circuit because it's a lot easier than any other circuit. If you're a beginner, then it would be much easier to do this circuit before any other circuit. So what you're going to need to make this paper circuit is some copper tape, a button battery, some scissors, and an LED. It can be any colour you like. You can have many different templates and you can find them online. You could have these, but for today, I'm just going to use this. Okay, so first you need to get your copper tape and you need to make sure that you have enough for the whole way around over here. So do not cut it where the corners are, because the sticky part of the copper tape, it's not very good with the connection. So if you just fold it, then it makes the connection a lot better. And the way you fold it is you fold it the opposite way where you want to go, the opposite direction, and then you put it on top of that in the right way, like this. So I'm just going to make sure that I have enough copper tape for the whole circuit. Okay, now that I have enough, I'm just going to cut it at the end. I'm then going to take the white bit off. Not all of it though, I'm just going to do a little bit at a time. Sometimes it's hard to get them separated, but you'll get there. So now I'm just going to stick it down. Okay. Making sure that I'm folding it at the corners. There we go. Now all of the copper tape has been stuck on. Now just cut the tape in between the two lines where the LED is going to be. Now I'm going to put on an LED, and there are two different sides. There's the short side and the long side. On your template, it should show where each of them should go. So I'm just going to put it like that. I have some tape here so that I can stick it down on top. And don't put it underneath the copper tape, make sure it's on top, otherwise it won't connect. Now the LED has been stuck on. And now I'm going to stick on the button battery. Okay, there we go. Now the button battery has been stuck on. And there is a bit where you should fold the paper, which is going to be there. So I'm going to fold it in the right place so that when you put it on top, it should connect. This bit should go on top of this and connect and light up the LED. Now my paper circuit works and it lights up. Here is a paper circuit that I made earlier. This one also lights up. I would also like to add that you should make sure to keep the button batteries away from children and animals, because if they swallow them, the effects can be devastating.
With my amateur radio background, I wanted to include some amateur radio style projects. So the first one we did was the Snail Morse Key, which was quite straightforward to construct. So we bought bits of wood and the cable ties and what have you, and they all made a buzzer. So of course they had to learn Morse code, which we did learn a few letters each week.
The Snail Morse Key was provided by the Hislop Radio Society and were our very first Morse keys. This was a simple build using a small slab of wood as the base, 2 drawing pins, a cable tie, a battery pack, and a buzzer that made sound. The key is very effective and easy to use. In fact, I used it throughout my beginner's Morse course with the Long Island CW Club. The cable tie goes around the buzzer, and that means that you can attach the drawing pin and poke it through, and it will stay in the same place so that it can make sound the same every time. There are 2 of the red wires, so I'm presuming these 2 ones from the battery and the buzzer, and they're connected to these 2 drawing pins, and when you push the top one onto the bottom one, it creates a sound. And when you remove your finger, it stops making the sound, so that's how you control the sound. When I send my name or something like an M, you just press it down for as long as you need and then lift it back up.
I came across the Sightron Arduino Kit. It was a very good price. You got the Sightron Arduino, which had built-in LEDs and buzzer, and had a breadboard with all the bits and pieces. And we went through the guide, learning how to turn on and off an LED, and worked through the guide to do the music. And once they mastered all this, we did some projects. Each child thought of a project. They said, what could I do? So we had a variety of projects. We had a piano using push-button keys, yeah. We had the parking one with the ultrasonic sensor and traffic lights, a whole variety of different projects which they worked on themselves.
Here I have the Arduino Maker Uno Kit, and I have used it to create a simple parking sensor. So if I turn it on and just see the red LED comes on, and the further it moves away, the further apart the beats are. And the Maker Uno is very good for this kind of thing because it has all sorts of step-by-step tutorials, and if you just want to make something with just sound or just LEDs, there are actually LEDs and a buzzer built into the kit. Here is the buzzer. It's very clearly labelled. They've done a very good job of labelling it. So here's the buzzer, and along this side here, where you see all these little holes, next to them you've got all these little LEDs. So you see some of them are flashing with the green one. And if I bring it closer, the one that turns on the red one also lights up. And in the full kit, what you get is the breadboard, the coding board itself, you get a motor and fan, you get some resistors to stop the LEDs exploding, and you also get a variety of LEDs and some capacitors to make it beep. Lots of different wires, and there's lots of other stuff you can get that's compatible or that you can buy separately, but the basic kit itself is, I believe, only around £16, so you can have a lot of fun with it for not a very expensive price. So this is an ultrasound sensor. So this part sends out a signal, and when it hits an object like my ticket, it bounces off and it's received by this part. And the time it takes, it's able to convert that into distance. On my laptop here, I have the code, and this is the setup, and here. So if distance is less than 3, which is 3 centimeters, it puts LED 7, which is the red one here, to high, which means it turns on, and it makes the tone a solid tone. But if the distance is different, then I've set up the code to make sure it has delays in between depending on the distance. I'm using the app Arduino, the Arduino app, and up here it's got verify, which is how you can make sure your code does not have any bugs, and here you can upload it to your board. If you have the kit, the instructions are completely free, I believe, and to buy the ultrasound sensor, it's not that much extra. And when I was making this, it was a good idea to use all different coloured wires, so I knew where each wire was going. And what I did is I took a photo so I knew where all the parts had to go. These kits are nice and cheap, but they work really well.
Yeah, these projects were so good that I thought they got to show these off to other school children. So at the Big Bang Science Fair, which is held at Pfizer every year, some of the girls showed their projects and showed their Snail Morse Key, and these are primary school children, but at the fair secondary school children came along, so they tested them. Do you know your phonetic alphabet? Can you say your name in Morse, all this kind of thing? And the secondary school children were amazed at what these year 5, year 6 children could do, and the projects they thought were amazing. So everything was going very well with their projects, and the Big Bang Science Fair, which perhaps at the time shouldn't have gone ahead with the COVID striking. This was in March 2020, but it went ahead, and as I say, COVID struck. So we stopped all activities for about 9 months, whatever, and nothing happened. But then we thought, well, let's do Zoom. So we did Zoom projects with the BBC Microbit, and it's not easy correcting circuits over Zoom. It was very difficult, but we got there. We did the basic things with the BBC Microbit, version 2, which is excellent because it's got a built-in microphone and speaker. You don't need an external one like the old version. So we were able to get the BBC Microbit to play songs, speak even, and they were able to do logic programs using the buttons A and B. And at the time, I wanted to learn Morse. So I went on a course, the CW Ops course, and I thought, why not do the same thing for the girls? So the girls, I enlisted on the Long Island CW Club course, which they kindly did 12 o'clock their time, so 5 o'clock our time, and the girls learned Morse. And that led then to the idea of Morse texting, using the buttons A and B for dits and dars.
We bought the Nano Key kits from Phoenix Kits to try building our own straight key for Morse code. They were quite simple to build with very good instructions and just one PCB connected to be soldered. We can connect the key direct to an amateur radio setup for sending Morse code or to our BBC microbits to use the speaker to create sound. So this is the Nano Key, and this connects into here, and you can connect it to the computers, but I've got it connected to a buzzer and a battery pack, and it makes the sound. There are a few things in the top here. I think they're just to hold the whole thing together. So there's a few things in there. This little ring here. But we have the board, and we had to put like everything in. It was basically there were no parts of it that were together already, so we had to do all of it. And these bits on the bottom are to help it like stand. We were sent the proper big Morse keys, and they were big. And we got to wire them up to a breadboard and make them work, and that was how we originally powered the Nano Key. And then we could of course plug it into the computer, and then we got these fixed on the end so it could connect to the microbit, and the microbit could send Morse code or use the speaker on it to send Morse code. When our first Morse radio communication was with Nigel, and we had a radio brought in and everything, and we plugged our Nano Keys into the thing, and we had a conversation there, and we were following like this script because obviously it was going quite fast. We would either use it for the speaker for the Nano Key, but we could also code the microbit itself to send Morse, and it would use the speaker to project it. And also at one point we connected or coded the microbit to send, but when we pressed it, it wouldn't. Normally it would come up on ours with the sound of the Morse, but it didn't. And we had two microbits. We coded both of them to send and receive. So we would put it on one, so we would send something like hello, and it would come out on the other microbit. But you wouldn't know if you got it right or wrong or not. So that would be one of the only problems with it. You wouldn't know if you got it wrong.
I got the idea of the telegraph from Joe and Julie, and they've got their grid with the battleships, so we use their grid to play the game Battleships, because you send square E5 sending Morse. So it's good practice of Morse, and it's fun as well. So yes, they enjoyed that very much.
Today, me and Caitlin are going to play a quick game of Battleships. And you can see my grid here. The X's are where I've put my battleships, and Caitlin doesn't know where they are.
We're using the nano key to send Morse via the microbit, using the cables which connect to the other microbit.
I'm going to send an E5.
It's a miss. I'm going to send a dit back so she knows she missed. Now I'm going to send back a B2.
It's a hit.
Yay!
There's an onboard radio on the BBC microbit, and we programmed it so that it could send dits and dars using radio waves. And we tested this out, and we got quite a big range, about 100 meters range between the two microbits. Yeah, so of course that then led to their article in Radcom.
Not that long ago, we had a small where we went down to the North Foreland Lighthouse, and we were going to send out Morse to see if anyone came back, and we also did some speaking over the radio as well, and that was quite fun. It was over the span of 2 days, and we got to speak to some people over the radio, and a few people came back on the Morse as well.
One of the coding projects we did with the girls was the Astro Pi. You've got the display, which is in colour, and we did the Mission Zero with the European Space Agency. You send a 30-second message to the astronauts on the International Space Station, but they have to code in Python. So not easy for primary school children, but they managed it. And this gave me an idea for animations. You can make pictures animate on the screen, and the children took part in an art exhibition at Margate, where they each did an animation to do with astronomy, because the theme of the exhibition was light and the cosmos. So we had different projects, the planets, the black hole, rockets, and so on. So they had to program the Astro Pi in Python to do this. So that's where the art comes in. So now they are the STEAMettes, because they've incorporated art. So science, technology, engineering, art, and maths. And the STEAMettes, is because we've ended up with only girls, and they like the idea that they're special. We're the STEAMettes. But they've since rebranded themselves the Morse Ninja STEAMettes, because they're so fluent in Morse. Radio Surfer Award has been a good incentive to get them doing things and giving me ideas, inspiration. And one of the things was the FunCube satellite. They downloaded a greetings message, which was personal to them, greetings to Millie and Caitlin and Alice. So they downloaded that, but they're now using it for a CQ, right? So there's a fitter message on the FunCube satellite, which is saying, CQ, CQ, please respond to Alice, Caitlin and Millie, and Natalie. Please send your QSL card, and they've got quite a collection already.
The FunCube is a very small satellite which is only 10 centimetres cubed. The FunCube satellite is a project to encourage young people to communicate with space hardware. FunCube 1 was launched in November 2013, and in December 2018, FunCube 2 was launched from Russia. It flies in an orbit above the Earth at 600 kilometers, and it is traveling at 41,000 kilometers per hour. It orbits the Earth every 90 minutes, and this is the FunCube. So the FunCube satellite is around 10 centimeters cubed, and here is a model of it with plastic straws and cardboard. We received a message from the FunCube using a large antenna called the Yagi Uda. The CQ message we received was our names. We have received cards from all over the world, including Slovakia, Indonesia, and even the BBC. So you can use this piece of software called the FunCube dashboard, where you can find out about the antenna temperature, and you can find out about the battery voltage and the panel voltage. You need a Yagi Uda antenna, which can be known as a Yagi, to point at the sky, which you can, and you have to do it at a certain angle, which you can find on the software.
Well, this Surfer Award gave me the idea that they should make contact with another country. So I wrote to the Dunkirk Radio Society in French, and they replied, yes, it'd be good to make a contact. So we set it all up, and they communicated with Robert, F1 FXN, and that went extremely well. I had my doubts if it would work. We just had a handheld and a Yagi going across the water there, but the signals were perfect, 5 and 9. Yeah, so great success, and it will lead hopefully to other communications with their scouts and our scouts.
F1 SXN GOHRS. Je m'appelle Caitlin, Charlie Alpha India Tango Lima India November.
Okay, Kathleen. Nice. My name is Robert, Romeo Oscar Bravo Echo Romeo Tango, and I'm living in Waplage. F-A-F-X-N 2G0HRS. Je m'appelle Alice. I understood immediately you were speaking French. Content de t'entendre, Alice. Tu feras un gros bisou à tes amis aussi.
Je m'appelle Natalie. November Alpha Tango Alpha Lima India Echo. Je m'appelle Millie. Mike India Lima Lima Yankee.
Hello, Millie. I'm happy to hear you this evening, and I hope to listen about you all another time. B73 88 for girls. This is F1 FXN transmission finished.
I have to say that Millie, when she first joined the group, was very shy, didn't like talking to grown-ups, was very not a child to put her hand up in class even if she knew the answer. And over the course of the last 2 years where she's been part of the club, she's come on in leaps and bounds. She's now able to stand up and present in front of large groups, talk to children who are a couple of years older than her to tell them what she knows and can help share her knowledge. It's built her confidence immensely, hugely. It's been fabulous.
Before COVID struck, I had in mind for them all to do their foundation license. But of course that was on hold. But now I feel they're ready to get their license. So we started training. They learnt about electric fields, magnetic fields, to understand a little bit about what microfaraday did, which then of course led to Maxwell's equations. I'm not teaching them the equations, but the idea that we have electromagnetic waves, which are radio waves. Yeah, so we're working our way through the course, and the technical aspects, it's GCSE level, but they're getting there. I've done some worksheets for them, so they're doing it practically based.
Next, they're going to do their radio licence, they're going to do their foundation radio licence and possibly their intermediate, which obviously they will use to communicate here in Planet and then across, hopefully, globally, and it will encourage resilience, which is what we want from young people today and we want from our 4 young girls. And so they will do a little exam, which hopefully they'll be successful with, and then know that they can achieve whatever they want to do.
We've been covering subjects, especially with the radio amateur licence learning, that they won't touch on in school until GCSE and even A-level.
It's been brilliant because they've had so many great opportunities to do activities that they didn't even think were existing. With the space station, they have been downloading images, for example, sending messages to a satellite. They've done wonderful things, and they've learned Morse code, which at such a young age is probably can be quite daunting, but they embraced it because they went step by step. They've done coding, and especially a lot of STEM, which a lot of girls are not predominantly thinking of doing. So what started as an after-school club soon became much bigger because they had an interest. They were having fun, they were with friends, and they were finding all these activities so different, so varied, and so interesting, and really happy to talk to their friends and say, well, I've done this and I've done this.
Give it a go, grab it with both hands, see what you can do, because it will be more than you think you can.
Yeah, have fun, and for the moms it's been fantastic. We're good friends, we help each other out. If one can't come to the meeting, then another one will look after the children. It's not a problem, and it's built really a great relationship. Even during lockdown, it's been fantastic for the girls. They have kept socially, it's kept them going, wanting to learn, and keeping some social interaction, learning how to communicate in Zoom. It's been really fantastic and a great build-up of their confidence, but our confidence as well, in showing them that STEM is also for girls and it's also for mums.
And it's great fun.
Wow, what about that? I'm sure lots of you watching this are my sort of age, maybe younger, maybe a bit younger or older, but it's so wonderful to see young people getting involved with this hobby, and I think they've done a fantastic job. So let's go over now live to Ramsgate and meet John and the STEAMettes. Hello, guys.
Hello.
You're live to the nation. It's really good to see you, and a couple of mums as well. Great to see you all. I mean, I really think a lot of people are going to see this and say, how does he do it? I mean, John, this started with a simple idea and it's now much bigger. How would you encourage somebody else to set up something like this?
I would say start in a primary school. It's more flexible in the sense that there's no pressure on GCSEs, that kind of thing.
And I mean, you youngsters there, by the way, I should introduce everybody really. So we've got, on the left, we've got Natalie, Millie, and then Alice. I mean, how old are you guys now? Are you about 11 or something like that?
12. I'm 12. She's 11.
11. All right, you're the youngster. That's okay. Well, you realise that a lot of other young people are going to see this, and a lot of parents as well, and going to think, oh, really, I'd love to do that sort of stuff. I mean, to the girls, what's been the most fun for you to do this? Because clearly you have to have fun, because this is not school. It's something you need to enjoy. What was your favourite bit?
Oh, we like meeting random people.
And talking to strangers.
Yeah.
Better explain that. We've done some special event stations, and we've made contact with people, and they're talking to strangers, which is fine. They're making friends.
Well, and of course we should just point out, because some non-amateurs may watch this and may be a little bit worried by that, talking to strangers, but of course one of the things is when you're a licensed amateur, we've all got a unique call sign, and because of that we're all traceable, so we're not complete strangers at least, are we? I've got a couple of questions for you. Firstly, from Pete M0PSX from Essex Ham says, what are your thoughts on a national STEAMettes movement or an online resource of projects to encourage similar groups elsewhere in the UK? Maybe to you first, John.
Oh, we've been talking about this. We think it's a fantastic idea. Yeah. Hello, Pete. Essex Ham. Yeah, there is an organisation, the STEAMettes. But we could link in with them. They could help us, perhaps. But I think it's a brilliant idea. Similarly with the resources. Yeah, pulling everything together, sharing ideas.
Yeah, lovely. And by the way, to all of you watching now, if you've got any questions to ask John or any of the girls or their mums, then please do so now. And also, if you've had any good experiences yourself and slightly different things maybe that you've been doing to encourage youngsters, we'd love to hear from you now. You can enter it on the YouTube chat channel, and we'll be happy to read those to John. Also, Pete came back and said for the STEAMettes, so for you, Natalie, Millie and Alice, he asks, what do your classmates think of your interest in tech? Is it easy or hard to get your friends interested in tech and amateur radio?
Yeah, we've just started in year 7, so we don't really know a lot of people in our classes. So.
Okay. Yeah, because I guess you've only been at school about a month or something like that, haven't you? But what about your group of friends, though? Maybe friends who aren't involved with this. Are they sort of jealous? Are they interested in getting involved?
I think some of them are quite interested, and they like that kind of thing.
Yeah, good. I mean, do you think this has encouraged you, again, talking to the STEAMettes now, I mean, does this give you more of an interest to make science relevant and maybe even think about a career in science?
Yeah.
Science technology, yeah? It's really good as well to hear that you're now studying for your foundation license, so I guess that may be... So what sort of time frame are you looking at that, do you think, John?
Well, hopefully by Christmas. Yeah, it's quite a few weekends lost. We lost last weekend because of Natalie's 12th birthday, so we couldn't do any training then.
Well, all right. I think we can let you off that, Natalie. That's for sure. And what about the mums now? Because obviously you've seen your children growing up with this technology and everything. Now maybe just over the horizon there's a thought of a license. So are you happy about that? And you going to encourage them to be able to put a radio at home, maybe in an aerial up, something like that?
Well, definitely. It's been wonderful for them to be able to get in contact with people all over the world, which is something they didn't think they could do. So, yes, it's been inspiring, and I think it does open their horizons as well. And they can see that they can do this type of thing, and they're more willing to try things new. So they're not scared of anything. They will consider, oh, yes, we could do this, or when before they wouldn't have done. So it's given them so much confidence and really an interest in technology, which a lot of girls don't usually go towards straight away.
Absolutely. I mean, it's not just young people here, but it's girls, and the girls are not always the ones to get into amateur radio. There's certainly still a lot more men than women and men and boys than girls getting into this hobby. Pete has come back with another question for the youngsters. Are you doing coding at school to this level, and what sort of tech do you do at the school? I know you've just explained that you've just changed schools, I guess, or changed classes, but are you doing this sort of work, the sort of coding that you were doing with electronics?
At school, our coding is quite pared back right now. We haven't really got into much coding yet. Because we haven't, we're still learning how to sort files in OneDrive. Yeah, we're still learning how to use the computers.
Do you know what? I think the trouble is going to be that you're going to know more than the teachers in some cases.
Yeah.
That'll be cool, won't it? To keep one step ahead. Well, look, all of you, thank you very much for coming, firstly for doing the film, but also for coming there live today. I know you only got in a little while ago because it was locked up, but it's really good sport of you to come there and answer some of these questions. You really are an inspiration, both to other radio amateurs to do something, that's you to John, and also you youngsters. You have been inspirational to other young people to show that this can be cool and it can be fun. And something else to do other than just play games that other people have written. Who knows, in a few years' time you might be writing your own games and coding in that way. So we'd really like to thank you all very much, both for the film and for joining us today, and all the best to you. And keep in touch, won't you? Keep the RSGB informed of progress with the STEAMettes Club.
Thank you. Thank you.
Thank you very much.